Hello, everyone. My name is Edgar Gutierrez Franco. I'm from the University Externado of Colombia. I am Colombian, and today, along with my co-authors Christopher Mejia and Cesar Niño, we'll present our research that is how to bring contextual optimization and agent-based simulation for delivery efficiency in developing countries. So this is our agenda. First, we talk about a little bit of our background, our research questions, the solution frameworks. They will talk about the use case and some key takeaways and research questions. So let's start with the background. This research starts in 2014 under a scholarship by Fulbright, Columbia, when we start studying predictive and prescriptive analytics for decision making. Then in 2019, we present our first case study for last mile that was with a company in Colombia. And then in 2019, we received an award from the National Science Foundation when we have the opportunity to understand more stakeholders. We conduct 90 companies interviews to understand what are all different challenges to do urban deliveries. So far, we are presenting 3 publications and 2 applied research projects. So today we'll present one of those. So in general, what is the problematic situation that we found out? First, technology mismatch. So the transportation management systems, when do the planning, there is no match between what is the plan and what is the execution. There are differences after we do the deliveries. Second, the capacity utilization versus the OTIF. Most of the operators trying to bring a lot of capacity in the vehicles, but they can't meet the OTIF's goals. And third, the product placement and the service time issues. So we have a heterogeneous fleet, and we have different sizes in volume and weight in our products, and we have differences in the service time. It is one of the problems that we will talk about, and we will talk about it. So the case study, this is a company. It's a big company, 140 years. It belongs to the home improvement retail stores. As you can imagine, they have thousands of SKUs and they have a much variety in volume and weight, so different products that we have to allocate in that heterogeneous fleet. So what is the research questions? First, how much does adding contextual features like the zone of the delivery, customer type, access rules, time of the day, reduce the service time prediction error and improve the estimated time of arrival for each of the customers? Second, what are the computational challenges, how we tackle those, and how we integrate analytical tools? So the solution frameworks that we call mantra, we have to take into account contextual information, vehicle planning, all the product allocations, and the service times. So usually the sources of uncertainty in this kind of problems are 3: the travel times, the demands, and the service times. But in our context, in developing economies, the travel time have limited variability and high predictability. Why? Because there is traffic always. These pictures doesn't matter the day of the day or the moment of the day. For example, in Bogota, we have a urban speed limit of 50 kilometers per hour. And after the study that we conducted, we find out that we in peak hours, we have at 16 kilometers per average, and in valley hours 22 kilometers per hour. So there is not much variety what is the velocity to one point to another. It's easy to calculate. The biggest unknown is how long each stop takes. So with the service time. So let me show you this example. As you can see, the associates have to park far away from the point of the delivery. They have to walk with the product. They have to deliver the product, and they have to come back again to the vehicle to take more products and come back again. And this is a townhouse. So imagine this can be happen in a building, 70 floor. They can go through security. And beside this, we have different infrastructure. We have small streets. We have a street with aisles, with downs, a lot of traffic. So all of that make difficult to have a better service times calculation. So our the first part of our framework is first with learning and then optimization. We go and conduct the data analysis, our machine and optimization model. So after the data analysis, customer masters or the backlog, mode parameters, integration with the data of the company, we go over the machine learning and optimization models. We know the estimated time of arrival depends on the travel time and service time. But after field observations and our analysis, we find out 50% in our data is used to perform tasks related to customer service and freight handling. So we create our machine learning. This is a neural network. Obviously, we have to take into account the location of our customers in the city. As you can see, each gray point is a customer. So we know the location, the vehicle type we will do the deliveries, the ordered weight, the ordered volume. So with that, we calculate the service time that we did for those. We train the model with the past data so we can predict that service model. So it insert as a parameter in our full model. So this is the full model, and you can imagine it works for small instances. So we have to create a partition of the model because we need bigger instances with 50, 60, 200 customers. So the three-phase heuristic decomposition. First phase, we identify the number of vehicle types that we need. So what is the size of the fleet and the type of fleet, heterogeneous fleet. Second, we do the clusters and assignment of products to those heterogeneous fleet. And third, we do the node sequencing. As you can see, there are three optimization models that are integrated, and we find out how to do the routing. In the second phase of our framework, we embed the machine learning model into the optimization model. We use the model from Gurobi. Gurobi already have a model when we can train the neural network and how to embed that neural network as a constraint in our optimization model. As you can see, this is the first model that we have. We have the service time here, and the service time is one of the constraints that is in function of the weight, volume, and density household. The variable here is the vehicle. What vehicle will we use? What is the vehicle type? And it depends on the structure of the optimization model. And that is heavily discussed in this seminar paper, Smart, Predict, and Optimize. So instead of having service time as a parameter, it becomes a variable in the optimization. So this is the case study. These are two instances, one with 87 customers, the other with 232. In the first one, the business assist use 13 vehicles. We use 10 vehicles, heterogeneous fleet as well. As I say, 46 tons in products. We go over 70% of capacity utilization to 97. And they spend around 2 hours and a half, and we decrease the time of planning the model, planning the routes in 11 minutes. And the bottom we can see for the 230 customers, we spend around 22 minutes planning all the routes and doing all the assignments. So with that, we go. We have to tackle other problems. We have to make sure how it behaves and how to make sure that the different complexities in the city allow us to have a better arrival and departure time for each customer. So we create an agent-based simulation. As you can see, this is the state chart for a vehicle. So the vehicles arrive to the customers, look for a parking, so they make some time, they do the delivery, and they go to the next customer. On the right, you can see this is the velocity for each part of the city. So we went over the city and we create those different zones. So let me show you an illustration. Each of those different polygons, let's say, have their own velocity during the day and have different times for find a parking, and obviously with the standard deviation and with the distributions that they have. So we can simulate how it behaves agent. So we already have our routes for the optimization models and how we can do it. So of course we have on the left for one vehicle, the arrival time, the departure time, and the service time at that part. On the right, we have the 70 vehicles for 250 customers. Some results, we decrease the number of vehicles that they operate. We use in different cities in the country. We decrease the kilometers traveled by vehicles. We improve the OTIF, and obviously we have better operations. So some key takeaways. We have 20-30% improvement in OTIF with the three-phase approach, reduce planning time. This method enhances vehicle utilization, cut costs, and ensure timely deliveries. We project calculation indicate potential savings around 9.5%. We reduce planning time and the 5-10% increase vehicle in the load efficiency. We want to, in future, apply research. We want to do inventory and routing optimization and to use imperishable routes. There are the main references that we use for this project. There's some acknowledgments for the different institutions and organizations. So thank you very much for your attention, and hopefully you bring these different frameworks in your countries. Thank you very much.